Alright, the next type of factoring we're going to talk about is the difference of squares. So this is just a special factoring pattern. So if we have two perfect squares, so if I have a squared minus b squared, so we have to see subtraction in between, then it will always factor into this pattern, where the first set of numbers is the square root of the first term, and then the second set of numbers is the square root of the second term, and then we'll always have a plus and a minus, so that way when we multiply them back together, the middle terms will cancel each other out and we will have 0. Okay. So if we take a look at 14, if we're going to factor that, the first thing that we need to be able to do is recognize that we have a perfect square. So if we don't have a perfect square, then this pattern isn't going to work for factoring. So x squared and 25 are both perfect squares, and we are subtracting in between. So I can do my double set of parentheses. I know I'm going to have a positive and a negative. So the square root of x squared is x, so that's my first term. Square root of 25 is 5. Again, so the next one, again, we have two perfect squares, subtraction in the middle. So we would have x and x, and then the square root of 9 is 3. And again, one's going to be positive, and one will be negative. And again, if you're not sure, you can always double check by multiplying these back together to see if you get this answer. All right, 16. Again, 9 is a perfect square and 25 is a perfect square. So again, setting up our double set of parentheses, the square root of 9x squared is going to be 3x, and then 3x. Square root of 25 we know is 5, and we'll have a positive and a negative. And again, the order that you write those in doesn't matter. We just need to have both sets. And our last one, so both 4 and 36 are perfect squares. Square root of 4 is 2, so we'll have 2x for the first term. Square root of 36 is 6. And then we'll have a positive and a negative. Now, this is a special case because we're not actually done factoring. So we should notice that both 2 and 6 are even. So that means that we can actually continue to factor using our greatest common factor. So we can factor out a 2 from each of these. So we would have 2 and then x plus 3. Same thing here, I can factor out another 2. And then we'll have x minus 3. So that means I need to multiply the two numbers together. So this would be 4. And then x plus 3, x minus 3. Now, the other way to do that is to recognize at the very beginning that 4 and 36 have a common factor. So we really should have started this one by factoring out of 4 to start with. So that would give us x squared minus 9. And then we still have our difference of square patterns. Okay. So we would have x and x, and then the square root of 9 is 3. And then we would have a positive and a negative, and that 4 would just sit in front. So either way, we would get the same answer. So it's really important that when you're looking at these, that you factor completely and you're looking for those common factors.